Hello everyone, in that video I would like to continue with the simplifier effect on GPU particles and show some more properties that could help to control the behavior, and also I would like to show how to connect the collisions, forces and so on. So let's go on. This is the previous result that I've shown in the previous video. So the final scene that I made during that video I will save into the GitHub repository into MB scenes folder. So and also all the binary of plugins for MoPlugs, MoRenderer and GPU particles, everything probably is on on MoPlugs repository. So you can find all things there. So let's open properties of our GPU particles here. So what I would like to achieve here in that video is that the smoke part should be more I think should be slower. So it's like the smoke is something very slow, so the fire part is something fast, and then we should lose our speed. So we can increase the speed from the very beginning. This is the speed which particles receive from the start. So the particles became very fast, and then during their lifetime, this is the damping. It's a parameter how fast they lose their existing speed, existing velocity. So this one is value when the particles lose their velocity, and now the particles start to moving very slowly, lazy. So that's probably what we need in that situation. But one more thing, that if we make mass bigger, that will make particles to behave to have more inertia, because there will be bigger mass, so there will be more inertia when we trying to affect different forces and change their motion. Then we could increase the global force of turbulence. So this is the global influence of velocity field. So it's a global space field force that we don't need to increase speed, I think, but we could play with the frequency, I think. So something very slow, lazy movement of smoke on top. So this is the fast part, and top part will be kind of smoke, slow and lazy. So that's parameter that could be useful in that in our situation, I think. And one more thing that I would like to achieve here as well is we could try to add a collision, just to show you how the collision works. So if we go in Assets browser, there is this physical properties particles. So that's the category where we have objects for our particle system. So there are collision sphere, collision terrain, the force, drag, motor and wind. So we can add a sphere and put it somewhere. So the sphere could have non-uniform scaling. It's not only the size, so we can do like that. And we also can assign and transform any transformation manipulations like rotation, translation and scale. So it's fine, and the particles will collide very well with that shape. And at the moment, in this version that I'm uploading on GitHub, I've added support up to 4 collisions, but I think in later updates it will be much more possibility that I will increase the limit of collisions. So we have several ways how we can connect the collision to particle system. We simply can drag and drop into the GPU particles. So that's, we will connect the collision already, and you will see that the particles stop on our collision. So now they have this kind of shape around the collision. And if we go to particle properties in the UI layout, we will see that in dynamic we have use collisions flag. So the collisions affecting particles, and we have collisions here in the list. In properties we have quite the same. If we go to dynamic properties, we'll see that there is collision assign and use collision. So if not use collision, particles freely move in space, but if we use collisions, they will stop by the collision shape. In collision shape there are parameters like friction and softness. So frictions is if the particles, friction 0 means the particles will stop on the collision surface and will not have any movement anymore. So they will stick, no friction. If friction is 1, that means the particles will trying to continue their movement but colliding with the sphere and trying to move along the collision surface. The softness means if it's a 0, no softness. The particles will be very hard collided to the surface of collision. If it's a softness collision, that means particles could move inside the collision, but they will lose their velocity. So that's in cases when, for example, for character we would like to make collisions for hands, and we want to do any effect on particles, but we don't want to make too much influence, so we can control the amount of influence with the softness parameter. So the bigger softness means the less influence collision will apply to particles, and without softness the collision will be hardly collide and pull out the particles from its volume. Yeah, and also collision, it's also trying to apply the current collision velocity. So if we move like that, we will apply velocity as well to particles. You see the particles is trying to inherit velocity from our collision. So it's trying to move the same as the collision in the same direction. So it's trying to, if the collision goes through the particles, it's trying to inherit the velocity of the collision. Alright, so thanks for watching. Hope that you liked that video, and see you in next videos about the MoPlugs and all the development. Thanks for watching, and bye.